Okay, in this video we're going to pick up with looking at the properties of duration and then move on into using duration and look at other measures of interest rate risk. So the first property here, the longer the time to maturity, the higher the duration, and everything else being equal is an important little provision to stick in there. But the maturity is going to be a very big part of duration. It's going to be the most important influencer of duration. Second here, the lower the coupon rate, the higher the duration. Again, everything else being equal. The Macaulay duration of a zero coupon bond is equal to maturity. So in the extreme, you have a zero coupon bond, we're going to have the highest possible duration for that bond. So that's where the duration equals the maturity. And I should say the Macaulay duration, the modified duration of a zero coupon bond will be slightly less than the maturity. The higher the modified duration, the greater the price sensitivity. So this is the important takeaway here. A bigger duration, a bigger modified duration number, the greater the sensitivity, the greater the risk of that bond in response to interest rate changes. And then finally, the modified duration can be interpreted as the approximate percentage change in price for a 100 basis point, that is a 1% change in the yield for the bond. So if bond yields go up 1%, then the bond price would go down by roughly the modified duration as a percentage. And we'll look at some examples here in a second. So here we're going to see how to use duration to approximate price changes. Duration is probably the most important measure of interest rate risk. It's one we care about, the one that you hear about the most. And the higher the duration, the higher the interest rate risk. The higher the risk of the bond changing in response to changes in interest rates. I should say the bigger the change in response to changes in interest rates. We can estimate the price change for a bond using the following formula. So the change in price, percentage-wise, that's the left-hand side here, is going to be roughly equal to negative modified duration times the change in interest rates. And we need to have that negative because of the inverse relationship between interest rates and interest rate changes and price changes. So this approximation is relatively close for small changes in interest rates, and we have a much bigger error with large changes in interest rates. Let's just go look at Excel and take a look at these calculations. So here we're using modified duration, and I'm going to look at a relatively small price change. What happens if we've got a 10 basis point change in interest rates, a 10 basis point increase? If we're using the modified duration that we calculated up here, 4.72, if we have a 10 basis point increase, we would multiply the modified duration times that 10 basis point increase, and that's what's shown up in parentheses there. We got a 10 basis point increase. We would expect, based on modified duration, a change in the price of negative 0.472%. Now down here I've calculated the actual change by just plugging into the formulas here, the pricing formula, the present value, using each of those different interest rates. And the actual change is a negative 0.47%. So again, those two numbers are very close. If we look at another example, what happens if interest rates go down, in this case 20 basis points, starting from 7.5% going down to 7.3. We use modified duration here, and my estimated price change is going to be an increase in price of 0.944%. The actual change, when we stick in and do all the math, we get an actual increase of 0.949%. So again, very close for small changes in interest rates. And we just looked at these examples in Excel, so I'm going to skip over this slide and move on to looking at dollar duration. So this is where we could use a slightly different measure and come up with a dollar price change as opposed to a percentage price change. So if we rearrange this equation here, the percentage change in price is roughly equal to the negative modified duration times the change in interest rates. If we rearrange some things and we put dp over dy is equal to negative modified duration times p, so just a little bit of algebraic manipulation. This right-hand side is going to be called the dollar duration. So negative modified duration times p, that is the price of the bond, gives us dollar duration. And we can use that dollar duration to estimate the change in price in dollars. So if we multiply the negative dollar duration times the change in price, we would come up with an estimated change in the value in the dollar amount of that bond. So as an example, for a 6-year, 8% coupon, 7.5% yield to maturity bond, this is the one we've been dealing with the whole time. We've got a modified duration of 4.72. The price of the bond is $1,023. So the dollar duration would be $4,830.91. Now, if we wanted to estimate the price change based on a 10 basis point increase, we would multiply that negative dollar duration, negative 4830, times the 0.001, times 10 basis points, and we would come up with an estimate of negative $4.83, a change in price of $4.83 in the downward direction. And that's what we're doing over here. This is the calculation using dollar duration for a 10 basis point increase. We've got a decrease in the bond value of $4.83. The actual change, looking up above, when we look at that calculation up here, the actual change is $4.82 in the downward direction. So dollar duration works very well, again, for small interest rate changes. Okay, let's move on and look at portfolio duration. The duration for portfolio bonds is going to be simply the weighted average duration of the bonds in the portfolio. So real quick and easy example here, we've got a 5 bond portfolio with the following weights and durations. We need to find the portfolio duration. So we've got bond A, B, C, D, and E in the following values. So this is how much the value of the bonds are in our portfolio. This isn't necessarily the par value. This is just the dollar amount that we have invested in those particular bonds. We got the portfolio weights, the durations, and then we're just getting the weighted average. It's 7.24 for this particular portfolio. That calculation is shown over here in Excel, where we got the bond, the value of the bond, the weight, the duration, and then the weight times the duration. We're just going to multiply each of those pieces, add them up, and indeed we get 7.24 as our portfolio's duration. So that's going to give us some sense of how much the portfolio will change if the interest rates for each of the bonds is going in one direction or another by about the same amount. So a handy measure, again, for risk across the bond world. All right, let's keep moving here and look at convexity. Convexity is another important measure for bonds, and convexity refers to the curvature in the shape of the plot of the price against interest rates. So I've got 2 different bonds here that I've plotted, and you can see the price along the vertical axis, the interest rates along the horizontal. And bond 1 has a very noticeable curve. That's the convexity of that bond. Bond 2 also is curving. It's not as easy to discern, but it's definitely not a straight line. There's some curvature to it. And so convexity refers to that curvature in the shape of the price interest rate curve. I think I want to pause here, and we'll come back and look at this slide and get into convexity in more detail in the next video. So I will see you then.